Good morning, welcome, thanks for coming. This is Collections Refueled, Collections Framework Enhancements in Java 9 and beyond. My name is Stuart Marks. I work in the Java Platform Group at Oracle. I work on the Core Libraries team, and I do my work in OpenJDK. So this is my Twitter handle, and I've created a hashtag for this talk. So if you have any questions, or we want to have a conversation about the subject matter here, anything we don't get to, if you can tweet on that hashtag, I'll try to respond to your questions. I've also put the hashtag at the top of every slide so that we can, so you won't forget it. All right. Real quick history of the collections framework. Java itself, JDK 1.0, was introduced in 1996, and it has what we now call as legacy collections. Vector and hash table. Anybody remember those? Anybody still using those? A few people using those. Okay, JDK 1.2 in 1998 was when what we now know of as the collections framework was introduced. That has all our favorite classes and interfaces in it, like list, set, and map, array list, hash map, and so forth. But there have been a number of major enhancements to it along the way. In Java 5, the language got generics, and the collections framework was generified. And so that's where all the pointy angle brackets came in. But it did improve the type system of the language. And so now using collections does not require casting when you get items out of it. And in Java 8, we introduced lambdas and streams, but we also introduced default methods, which is the ability to add new methods to an interface, which has not been possible in the past. And so what that enabled was the ability to add default methods to the collections interface meant that every single existing collection, even without being changed, every single existing collection was enhanced with those default methods. And so continuing after Java 8, we've introduced some new enhancements to the collection framework. In particular, a new set of APIs we're calling the collections convenience factory methods. They let you create collections with a known set of objects in a very clean and concise manner. They are backed by new collections implementations that are considerably more space efficient than the previously existing ones. And most notably, is the fact that they are unmodifiable. So I'll get into some characteristics of these new collections implementations in a moment. A bit of background here. This is a library-only change. Various people have asked for collection literals to be added to the language, and various other languages have collection literals. We decided not to do that. Instead, we decided to pursue a library API-based only. Library API system only for creating collections conveniently. And so the reason is that it's enormously difficult to change the programming language, and we felt that a library API would cover about 80% of the use cases very well. But I think another subtle point about doing this is that if we were to add collection, or if we had introduced collection literals to the Java programming language, that would have created a tight binding between the programming language and the existing collections framework, which is something we were uncomfortable doing. So if you look carefully at the system, there is a fairly loose coupling between the language and the libraries, and that is mostly embodied in the java.lang package, and we try to keep those dependencies there. All right, so let's look at the new APIs. Basically, it's a bunch of methods on list, set, and map. So there's list.of taking 0 through 10 arguments and varargs, set.of 0 through 10 arguments and varargs, and map.of. Map is a little bit different. Since the key and the value can have different types, there are pairs of key and value arguments, but then you can't use varargs. So then there's another method called map.of entries that lets you create a map with an arbitrary number of entries. And then there's a convenience method, map.entry, lowercase entry. That's a method that creates an instance of a map.capital entry. And so if you're familiar with that segment of the code, the easiest way to do that before was to create an instance of abstract map.simple immutable entry. So it's much easier to just say map.entry. And especially if you static import it, it makes things much nicer. And I'll show an example of that in a little bit. All right, this is the Java doc for the map class, and it's a little unfortunate. You can see there are a whole bunch of overloads with different numbers of fixed arguments. And the reason we did that was for efficiency, because even though we have var args, what that does is it creates an array and copies all the elements into it, and then the elements have to be copied out into their destination data structure. So using var args imposes additional overhead that we did not want to force people into. So we have provided a large number of fixed arg overloads. Now, when I posted the proposal for this, somebody on Reddit said, "Is this a joke?" And it is, you know, it is kind of messy, I'll admit that. But the way we design the libraries is we're willing to put up with a certain amount of messiness in the library to make things easier for application programmers. And so, in fact, even though this API does have a lot of clutter in it, you don't see this when you program with it. You can just say map.of and then add the right number of keys and values, and you're done. All right, so let me run through some examples here. So let's start off an example of creating an unmodifiable list. In Java 8 and earlier, I'll read it from the inside out, actually. So we want to have a list with A, B, and C in it. So the easiest way to do that is to use arrays.asList, and then wrap that in collections.unmodifiableList, which puts a wrapper around it to prevent that from being modified. And then we assign that to a new variable. Now in Java 9, you can just say list of ABC. And of course, now that I'm looking at this, I should have said for Java 10, you can say var string list equals list.of ABC. But that's not what this talk is about. Anyway, so you can see that's much easier and convenient, more concise than creating an unmodifiable list the old way. Set example is pretty similar. Now in this case, in Java 8 and previous, there's no var args, there's no convenient var args way to create a set. So we started off once again with arrays.asList, copy it into a set, and then wrap the unmodifiable set wrapper around that. But in Java 9 and later, we can just say set of ABC. Pretty simple. All right, map is where it starts to get a little interesting. Now, since the keys and values are different types, you can't use a straightforward var args approach. And so what you often see people doing is resorting to basically this straightforward block of code where you create a map, create a hash map, have several calls to the put method that put the key and value methods, key and value pairs that you want in, and then you can wrap that in an unmodifiable wrapper. And so in Java 9, the map.of method has alternating key and value types, so you can just put one after the other. But there's a limit in doing that. You can only have up to 10 key value pairs when you use map.of. All right, what happens if you want to put more than 10 entries into a map? Now here's where it starts to get a little more complicated. The first thing is there's a var args method map.ofEntries that takes a var args list of map entries. And then now how do you create the map entries? And so that method I mentioned earlier, I've statically imported that here. So that's just a method call on each line called entry. And that takes one key and one value. And then you can stack up as many of those as you want. So yeah, I think that's all I have to say on that slide. Okay, now I think this is the more interesting bit of the talk, because we're going to dive into some of the issues about using these. Like I said earlier, these are new implementations of the collections. So when you say list.of, you don't get an array list. You get an implementation of a new class that's private to the JDK. And then same with set and map. So these don't create array lists, hash sets, and hash maps. What you get is an instance of some implementation of the list, set, or map interface. And so you can use those anywhere those interfaces are required in your program. But those implementations have characteristics that are quite different from the existing implementations that we know and love, like ArrayList and HashMap. And so in particular, they are unmodifiable. So they're not wrappers around other collections. They are themselves unmodifiable. So once you get one of these new lists, you cannot change the elements. And then further, if the elements of that list are themselves unmodifiable, then the whole thing becomes immutable. And so if you've been following trends going on in the industry with functional programming and data parallelism, you'll understand that immutability is a pretty big deal these days. And so these are collections that are by default, well, we don't say that they're immutable because you can put a mutable object inside of one of these, and the whole thing is still mutable in that case. So we say they are unmodifiable. And so it's much easier to use these to create immutable data if you put immutable elements inside of an unmodifiable collection. Okay, so another characteristic of these is that nulls are disallowed. So you'll get a null pointer exception when you try to create one of these with nulls as any of the elements or key or value entries. So quick show of hands, does this bother people? Anybody who this bothers, if you raise your hand? Nulls disallowed. The nulls, disallowing nulls. Just want to get a quick read on that. A handful of people, okay. If any of you want to stick around, let's talk about it afterwards. So we have a difficult relationship with nulls. There are other programming languages that have null safety in the type system. It's difficult to retrofit that into Java for a variety of reasons. But the fact is that, I forget the exact release, but I think that every collection that has been added since about JDK 1.4 disallows nulls. So we are slowly trying to push people away from nulls, and that's unpleasant sometimes as well. But we didn't want to go back and set a precedent to say, oh yeah, we're allowing nulls in these. But we'll see. But anyway, so JDK 9, 10, and 11, nulls are disallowed in these collections. Okay, now here's an interesting one. Random iteration order of set elements and map keys. So one of the problems we've had over the years is that a hash map is a very popular data structure, and quite often you want to iterate over the entries of a hash map. And what happens is that when you put the same data into a hash map, formally, the order in which those entries are iterated is unspecified. However, it is very predictable. And in fact, if you put the same data in practice, it will always be iterated in the same order. And the problem is that people write code that starts to depend on that iteration order. And this isn't just sloppy programming. It's actually kind of difficult to inspect a bunch of code and determine that it has no iteration order dependencies. And so what we found is from time to time, in order to either fix security holes or to enhance the performance of the collections or things like that, we've had to change the iteration order of things like hash map. And this ends up breaking a lot of code. And so on the one hand, don't change the iteration order. On the other hand, when we evolve the JDK from one release to the next, sometimes we have no choice. We have had to make changes, for example, in order to fix security holes that have caused changes in iteration order of some of these data structures. And so in one sense, we'd like never to change the iteration order, in fact, to specify it. That's kind of one stable point in the spectrum. But the other stable point, well, the fact is it seems like a stable point, but it's not, because we've been forced into situations where we've had to change that, and that breaks code. So instead what we've done is we said, okay, let's go to the other end of the spectrum and say, we're going to randomize the iteration order. Actually, I'm going through all of my talk here. I have a whole slide on this. Anyway, so but that's the issue that's set up there. Duplicates are disallowed. So if you're writing out individual elements in set.of, if you put two of the same element, it is probably a programming error. Like I said earlier, they're space efficient, and they are also serializable. So if you need to write these to a persistent store or something like that, you can serialize and deserialize these instances. All right, so I will get back to actually each of these issues. So I had a question when I've given this talk before about what use is an unmodifiable collection, and so I've been so close to this, it hasn't occurred to me. But the fact is, having an unmodifiable collection helps preserve encapsulation. So if you have an internal data structure and you write a getter, suppose you have an internal data structure that's an array list, and you write a getter and you simply return that array list. Well, whoever has that reference can modify that array list, but that's part of your internal data structure now. So maybe you can tell people don't modify it, but maybe the person who's using it didn't get that message or didn't read the documentation or something and says, oh, great, okay, now that I have this list, I'm going to add things to it, but now it's corrupting your data structure. And so that's a potential for bugs to creep in. And so one way around that is to make a defensive copy, or another way around it is to use the unmodifiable wrappers, like I showed earlier, collections.unmodifiable list, for instance. And so with these, they are inherently unmodifiable. And it turns out it's quite a common use case to say, all right, I'm going to have a class. I'm going to initialize some data in either a static initializer or in a constructor. Once I've figured out how things are set up, I'm going to create a list or a set or a map or something, and then I'm never going to change it. It turns out that that's a very common use case. So if you're never going to change it, having the library enforce that it can never be changed is actually very useful. And then if you write a getter for that, you can just hand out the reference to it, knowing that if you hand it out to somebody, they can never change it either. So that's the rationale for making these collections be unmodifiable. All right, so there's a little bit of subtlety here. These collections are themselves unmodifiable, whereas if you look in the collections class, there are a bunch of utility methods like unmodifiable list and unmodifiable set and map. And what those do is create wrappers around another collection. So what those allow you to do is if you have an existing collection like a hash map, you can wrap that in an unmodifiable map and then hand that out, and that protects it. But that doesn't mean the thing is immutable, because if you still have a reference to that inner data structure, you can modify it. Or in fact, anyone who has a reference to that inner data structure can still modify it. So those wrappers are different from these new collections implementations. These new collections implementations are inherently unmodifiable. So in fact, all of the mutator methods like add or put, those unconditionally throw unsupported operation exception. So once you've created one of these, and well, you create it and populate it at creation time. And once it's been created, you have a high degree of assurance that it can never be modified. All right, so nulls disallowed. I spent a little bit too much time on this earlier, but I want to hit a couple extra points here. So if you create a list setter map using list.of, set.of, map.of, or whatever, any nulls in there will cause a null pointer exception. The general sense is that allowing nulls in the original collections back in JDK 1.2 was a mistake. It creates a bunch of special cases in the collections code, which means that it slows things down. Also, you get some strange problems in the API. For instance, map.get returns null if the key you're asking for isn't there. Oh, but actually it also returns null if the key is there and the value is null. So that's a problem, because null is being used either as a sentinel or as an actual value, and you can't tell the difference. So if we adopt a null-free programming style for using collections, then these problems go away. All right, randomized iteration order. I think I talked about some of this already. Officially, the iteration order is unspecified. And so things break when the iteration order is changed. So even though the specification says that the iteration order is unspecified, from our point of view in the JDK, we can say, hey, well, it's not specified, so that means we can change it anytime we want, right? But like I said earlier, the fact is that the iteration order is predictable and it's stable for multiple releases, and so code starts to build up these inadvertent dependencies on it. And so instead what we're doing here, and this applies only to the new collections implementations, this does not apply to the existing ones like hash map and hash set and so forth, but the new collections implementations will randomize the iteration order. So if you load up a set with set.of and you load it up with some data and you iterate that set, it'll come out in some order. It's unspecified what order it comes in. And then if you run the application again, the randomization takes effect whenever you start up a new JVM. And so if you start up a new JVM and load a set with the same data using set.of, you'll probably get those elements in a different order. Now, won't that cause a bunch of bugs or something like that? Well, it might. But what the intent is that if you happen to write code that depends on the iteration order of a set or map, that you'll catch that in unit testing. Because if you're doing testing, you're constantly creating new JVMs for test runs. And so probably the iteration order is going to change fairly frequently. And so if your tests, what this will manifest itself is that some of your tests will start to become quite unreliable if you have iteration order dependencies. So that's our hope, in that the iteration order is randomized and changed frequently enough that any accidental dependencies on iteration order in client code get caught during testing, and that they don't escape into production. And so, sort of a big experiment, but the alternative, which we've lived through several times before, is we've had to change the iteration order even in patch releases, like for security updates. And that breaks a lot of code, and people don't like that because they want a drop-in replacement. So the goal here is to toughen up client code so that to flush out any iteration order dependencies that code might have before it gets into production. Now, if you do have code that depends on iteration order, then you can use a list. List does not modify its iteration order. Inherent to a list is they're in a particular order. Or if you want something like a set or a map, but that does have a defined iteration order, there are other classes already in the JDK, linked hash set and linked hash map, that do have predictable iteration order. And so one potential fix is, if you do have dependencies on iteration order that you can't root out, then switch that code to use linked hash map or linked hash set. If you look at the whole software industry, this is not, I think you're all here because you're Java programmers, but many of you probably use other systems as well. And so I think it's actually helpful to see what's going on in the rest of the industry. And so everybody else is wrestling with this problem too. In particular, I'm aware of two other programming systems, Go and Python, which have dealt with this. And from the beginning, as I understand it, Go has, I forget what the data structure is called, a map or a hash map or something like that. The iteration order of those has been randomized from day one, and I don't think it has been changed. And so every piece of Go code has dealt with this potential randomization of iteration order. Now in Python, it's kind of interesting. In Python 2, which everybody was on for a long time, they tried to walk this fine line, which was officially it was unspecified, but it had predictable iteration order characteristics, but you weren't supposed to depend on them. And then so in Python 3, they changed the hash data structure in Python so that it actually was randomized. But then I think in Python 3.6, they went back. Somebody said, well, I found a much better way to represent a hash in Python, and in fact, it allows us to provide a predictable iteration order. But if you look at the Python specification, it still says, well, it's not specified, even though the iteration order is predictable. So I think this largely depends on the taste of the implementer. But of the map data structure itself. And this is important to some people, and it's not important to others. But as I understand it, the official line in Python is, if you write a loop that depends on the iteration order of a dict, that's what it's called in Python. Sorry, not a hash. Wrong language. So anyway, so if you're iterating a dict in Python and you rely on the iteration order, there's something called an ordered dict. And that's what you should use. Just like I just said, use linked hash map or linked hash set in Java if you need predictable iteration order. Okay, again, I want to stress this only applies to the new collections implementations for set and map. It doesn't apply to list. It doesn't apply to existing map implementations like hash map. Okay, duplicates are disallowed. So the idea, well, again, only for set and map. For list, of course, you can have duplicates in it. So the idea is that this is an API that is sort of like collection literals. So if you're writing out a set of constants for something that is supposed to be unique, such as a set or map keys, if you have duplicates of those, that is probably a programming error. So if you look at other systems, there is often some policy like last one wins. And although there are a few notable exceptions, like Clojure has a mode, and ECMAScript in the strict mode has a mode where if there are duplicates added, then it will raise some kind of error or something like that. So let me show an example of this. So remember earlier I said you can use the map.ofEntries method to add more than 10 key value pairs to a map. All right, so did I add a duplicate here? Oh yeah, I did add a duplicate here. Can you spot it? And so I think the thing here is that if you have a long table of these, it might be pretty easy for a duplicate to creep in accidentally. And what happens is your data structure is effectively corrupted. And maybe you might catch this in testing, but if you're unlucky and don't catch it in testing, then you get the 3 a.m. call and you're staring at this code bleary-eyed with a cup of coffee trying to figure out where the duplicate is. And yes, there is a duplicate. Yeah, I used vertical bar instead of exclamation point. Right? So that's the idea. So if you write this code and run it, we can't do this checking at compile time, unfortunately. So at runtime, this will fail immediately because it says, oh, well, you have a duplicate key here. You're attempting to add to this map. Okay, so another characteristic of the new collections is, at least particularly for set and map, is that they are much more compact than the existing ones. And so if you've ever looked inside of a hash map, it's actually pretty amazing how many little objects it creates inside there. And there's good reason for it, because hash map is very, very fast. But what hash map does is it makes a space for time trade-off. So it creates more objects so it can find them very, very fast. And so the set and map implementations we have now make a different trade-off. The fact is they're somewhat slower than hash map, but they are much more compact. And these days, with if you saw Mark Reinhold in the keynote talk about memory latency and the cost of cache misses, if you have a lot of objects in a linked data structure, then those have high probability of causing cache misses. And so what we've done with these data structures is we've tried to make sure that the data is held with very high locality. So it might be, so I said earlier that these collections are slower than hash map, and they are. If you benchmark them, they are. However, they're not that much slower, because we hope that the fact that they're using less memory and memory that is more localized will prevent cache misses. All right, so let's do a quick analysis of the space usage of hash set in this case. Okay, so it's a little odd. I want to create a hash set with enough space to store 2 entries, and so I actually have to create it using a capacity of 3. That's because of the load factor. That is unfortunately a counterintuitive aspect of the API. Anyway, so we create a hash set, add a couple things to it, and then wrap it in an unmodifiable set. So if you count up all the objects that this creates, we have, let's go from the outside in. We have the unmodifiable wrapper. We have the hash set itself. Inside the hash set, it's actually implemented in terms of a hash map. So it has a hash map instance. So a hash map, the internal organization is, it has a table of objects, which is an array, and then the table contains node objects, and those are each individual objects. So here's a picture of that. So basically, that's a picture of what I just said. So that's what the conventional unmodifiable set looks like. All right, now let's go through these objects and count up the number of bytes consumed by each one. So It depends. So these numbers depend on the JVM implementation, but I'm going based on Hotspot, which has even if it's a 64-bit JVM, it still allows it has a feature that allows use of 32-bit pointers, and so in this case, every object has a header which happens to be 12 bytes, and then so every object unavoidably has an overhead of 12 bytes. So that's the first thing. And then in addition to that, there's the data for the actual object itself. And so I have an accounting of it here. The details aren't really all that important, but if you look at that graph of objects on this slide, if you count up all the object headers and then the fields within these objects, then you get a total of 152 bytes. But this is just a set containing 2 elements, and and I'm not even counting the strings themselves, right? This is just the overhead in the collection of storing 2 elements. And so if you have a lot of small collections, then the overhead of collection space actually can outweigh the elements contained within it. And I think that's the case that's going on here. All right, so the new set implementation is much more compact. And so what we do is for small collections, instead of having an array, which is a separate object containing the elements, we actually have fields that store them. And so currently, and this is subject to change based on various performance trade-offs, but currently if you have a set or map, not a map, sorry. If you have a list or a set that contains 0, 1, or 2 objects, then there's no separate array to contain those. So you save a lot of space with small collections. All right, so in this case, we say set.of foo and bar. And so we create one object, which is the internal set implementation. And that has 2 fields. And those point directly to the strings foo and bar. And so that takes the amount of overhead. Again, I'm not counting the strings themselves. The amount of overhead to store a set of 2 objects is 20 bytes, as compared to 152 bytes for the previous example. All right, so I talked a lot about set.of, map.of, and so forth. And those are for initial construction of collections based on essentially constants that you write out in code. So we've continued to evolve things in JDK 10. So often it's the case where you might want to do some computation and build up some data in a mutable collection, like an array list or in a hash map. And then when you're done with that phase of your program, then you want to snapshot it into one of these unmodifiable data structures, because after that point in your program, you know it's not going to be modified anymore. So that use case is not well supported by the Java 9 APIs, so we added a few more in Java 10. So here we have the ability to create a copy of another collection, list.copyof and set.copyof. Notice that those take a collection, and so that's interesting. So if you have, so this is a common case here. One of the things that was that I think there was a legitimate complaint about the previous APIs was, suppose I have a bunch of items I got from somewhere and I want to deduplicate them and store them into a set. If you call set.of, that will throw an exception if they're duplicates. So sometimes you really do want to throw away duplicates. And so you can do that with set.copyof. That has slightly different semantics where it does allow duplicates. And then I actually, I think I left it unspecified as to which duplicate is used. But if you have a bunch of things and you want to deduplicate it, if you have a collection of these things, you can just throw them into a set using set.copyof instead of set.of, and that will compress out the duplicates and then give you an unmodifiable set. So there's a little wrinkle here too, which is that quite often it's good practice to do defensive copies of data structures. If you, like I said earlier, if you have an internal data structure and you want to hand that out to somebody, or you want to hand the data to somebody, but you don't want to actually hand the reference to your internal collection, maybe you might want to make a copy of it first. Or if somebody hands you a collection, I think this is actually a little more compelling example. Somebody hands you a collection and you want to take the the elements from that and store them in your object. Well, you're probably not going to take that reference and store it directly in a field, because who knows what the caller is going to do. The caller might reuse that data structure for something else. And once again, you have the case of somebody outside who's modifying the state of your the internal state of your object. And so the good practice there is to do defensive copy. So if somebody hands you a list of something, you might want to say, okay, I'm going to create a defensive copy. And so you can use list.copyof to do that. Now, in fact, I'd encourage doing that. But that raises the question of, won't we be making a bunch of redundant copies? What if my caller has also adopted these unmodifiable data structures? Well, it turns out we designed it this way, of course. If you have an unmodifiable data structure and you call copyof on it, it just returns the same object, because it's unmodifiable, so there is no penalty for sharing. There's no need to do a copy because it can't be modified. So what I'd encourage people to do is to create defensive copies using these copyof methods, because they will short circuit the copy if it is determined that it is safe not to do the copy. However, if the source is a mutable data structure, it will do the copy and then return an unmodifiable copy of the same elements. And then finally, there's another use case, which is you might want to be performing some computation using a stream instead of building up things in a collection. So if you have a stream and you want to dump the output of a stream into an unmodifiable collection, we've added a family of collectors, 2 unmodifiable list, set, and map, and there are a couple overloads of map there. Again, these do allow duplicates, and they will compress out duplicates, so you only get one entry in the resulting set or map. And then the last one has a merge function which lets you handle duplicates explicitly. Okay. All right, we've reached the summary here. Collections framework is 20 years old. I think it still has legs. I think everybody is still using the original list, set, and map interfaces. We're continuing to enhance them. In JDK 9 and 10, we've added a bunch of additional APIs that I think really expand the power and ease of use of the collections framework. And that's basically it. So you can contact me on Twitter, either on that hashtag or directly. And it looks like we have a few minutes left. Oh, the guy gave me a 5-minute warning, so 5 minutes for questions. And so somebody over here had his hand up first. So it was, this gentleman.
When you were talking about randomized iteration, I was a little bit surprised to hear it, because I agree that randomizing the iteration order can help you identify that you have an iteration order dependent bug. Is there any easy way to identify what your iteration order dependent bug is? Because I frequently rely on the fact that between runs in the same version with the same precise data, I get the same iteration order for my debugging. The code doesn't depend on what I do.
Okay. Well, it's a little involved. I think okay. So the question was about iteration order, and I'm actually not sure what the question is, but for debugging or something like that. So I guess within the same VM, I mean, officially it's unspecified, but within the same instance of a VM, the iteration order does not change. So maybe that makes you feel a little more comfortable. No.
I rely very much on bug recipes.
Yeah.
If you do the following things, the following
Right.
bad thing will happen. And it seems to me that creating a new random order each time.
Yeah. So, yeah, okay. So, I mean, so this is tough because it is so dependent on the application. So I'll attempt to repeat the question. So the randomized iteration order will potentially help detect iteration order dependencies, but it doesn't help you find them. Is that a fair way of putting it?
More than that, it harms your previous attempts to find them.
It harms your previous attempts to find them. Well, I suppose so. I guess, so I think it's difficult because let me tell you about problems we've run into in some of our own applications. And the fact is, it is very difficult to find these. And I don't know what the collections framework itself can do to prevent this. And so what we found is that there are a lot of things that will iterate over a data structure, and the processing of each node in that data structure will have a side effect. And so you think about the composition of all the side effects that occur when iterating this data structure in a particular order. And ideally, maybe, those side effects should be order independent, but sometimes they aren't. And so what we've run into is cases where they aren't. And we've had things escape into production because of that, because they weren't noticed. And then something small changed that did change there was a slight difference in the data that caused the change in iteration order, and then a bug manifested itself. It's like, how did that happen? We've tested this code very thoroughly. And so, so then it's how do you reproduce that? And so that's a difficult question. I don't know. I think the thing is, with collections, it's basically if you have something that has a particular iteration order, then I think about the only thing I can say is, selectively substitute in linked hash set or linked hash map. And in fact, in the case I was talking about, we couldn't find the bug. It was actually pretty disquieting. We couldn't find the bug. But it's like, I think it might be this hash map here. So we substituted a linked hash map, and the problem went away. Now, my contention was that there was still a bug in there, because if the data changed again, then we might get the same problem. But other people were convinced that we'd fix the bug. So I don't know how to help you with this, because this is a serious problem. And I think that the fact is, though, even if we didn't have randomized iteration order, if there are sometimes things that cause changes to your data. And it's true. It does sometimes hurt the reproducibility of bugs.
I rely very much
Yeah.
on determinism
Okay.
between runs.
Okay. Okay. Excuse me, sir. We have. Yeah, I know. Okay. Up. He says time's up. All right. Well, I'll. No. No. Okay. All right. Well, thanks for coming.